Okay, so let's take a look at this first one. So what is a domain and range of this first one? Well, this is a cubed function, so it looks like that. So our domain is all reals, and our range is also all reals. So to find the inverse, we switch our x and y. So x equals y minus 3 cubed plus 4, and then we solve for y. Minus 4 minus 4. And then let's take the cubed root. So our cubed root of x minus 4 equals y minus 3, and then add 3. So we have the cubed root of x minus 4 plus 3, and that's y, so I'll denote it with our inverse. And so our domain, again, they flip-flop. Well, they're just all reals, because our domain and range of our original is all reals. So our second one, well, this is just a line. So what is our domain of the originals is all reals, and our range is also all reals, because that's just a straight line. So let's find our inverse. So x equals 1/7 y plus 6. So I'll subtract 6, and then I'll multiply by 7. So we have 7 times x minus 6 is our inverse. And again, if we flip-flop them, these are just all reals again. All right, so this next one, well, we already have our domain restricted because this is a parabola, and we know it's a parabola to the right 1 and down 2. So this is just saying x is greater than -1, so that half. So our range is greater than or equal to -2. All right, well, if we flip-flop this, so x is equal to x plus 1 squared minus 2, y plus 1. So we'll add 2. I don't know why I put it in parentheses. And now we'll take the square root. So the square root of x plus 2 equals y plus 1. And then minus 1. So our inverse equals the square root of x plus 2 minus 1. And normally we plus or minus, but we know our domain here. We know our domain is x is greater than or equal to -2. And our range is y is greater than or equal to -1. So that'll take care of our restrictions there. All right, what about this one? Well, we know that this is a square root, but it moved to the left 2 and down 3. So it looks like that. So x is greater than or equal to -2. Y is greater than or equal to -3. So then down here, we could flip-flop that already. So y is greater than or equal to -2, and our range greater than -3. And then to find our inverse, so we swap them. X equals the square root of y plus 2 minus 3. So let's add 3. And then we can square each side. And then we can subtract 2. So we have our inverse equals x plus 3 squared minus 2. All right, so this one, let's see, it's a parabola, but we have our restriction of x is less than 2, and we know it moved up 5, so y is greater than or equal to 5. So down here, that means our domain is greater than or equal to 5, and our range is less than 2. All right, so let's flop these. So x equals y minus 2 squared plus 5. Minus 5, so x minus 5, y minus 2 squared, then the square root, and then let's add 2. So there is our inverse. All right, and now this next one. So this is a little different. If we were to graph this, remember, we could look at Desmos here. We had 2 divided by x minus 1. So it's those swoopy graphs. So if we remember that, again, it's going back to last unit. Our vertical x can't be 1. And our horizontal Where's our asymptote? Is at 0 because the numerator degree is less, so y can't be 0. So for our domain, it's all reals except x can't be 0, and our range is all reals except y can't be 0, or y can't be 1, sorry. So let's see, if we swap this, x equals 2 over y minus 1. So let's multiply by y minus 1. So we have y minus 1 times x equals 2. We could distribute, so yx minus x equals 2. Add x. So we have xy equals 2 plus x, and then divide by x. So we have our inverse equals 2 over x plus 1. All right. So what about this one? Well, let's see. This is a parabola, and it's moved down 1, but it's flipped. So I know that it moved to the left 4 and down 1, but it's flipped. So I know it has to be like that. So I know that y is less than or equal to negative 1. So if we flop those, I could say y is less than or equal to negative 4, and x is less than or equal to negative 1. And then we can flip-flop. So x equals the opposite of y plus 4 squared minus 1. We add 1. So x plus 1 negative y plus 4 squared. I'm going to divide everything by negative 1. So if I divide those each by negative 1, negative x minus 1. Square root. So the square root of negative x minus 1 equals y plus 4. And then subtract 4. So negative x minus 1 minus 4 equals our inverse. All right. This next one, let's see. What is this one? Just move to the left 1 and up 3, but it's flipped over, so it's got to look like that. So I know x is less than or equal to, or greater than or equal to negative 1. And y is less than or equal to 3. So our range, y is greater than or equal to negative 1, and x is less than or equal to 3. And then let's flop it. So x equals negative the square root of y plus 1 plus 3. So I'll subtract 3. Got to get rid of that negative, so divide everything by negative 1. So negative x plus 3. Square each side. And then subtract 1. So negative x plus 3 squared minus 1 is our inverse. All right, and the hardest one, the fraction one. So again, our denominator can't equal 0. So that means x cannot equal 4/3. And if we look, our degree's the same, so y cannot equal negative 2/3. So down here, our range, again, it's all reals, except x cannot be 2/3. In our y range, it's all reals, except y cannot be 4/3. All right, so this is the tricky one. So we're going to switch the x and the y. So x equals 2y plus 5 over 3y minus 4. So multiply by 3y minus 4. So now I have 3y minus 4 times x equals 2y plus 5. I'll distribute, so 3xy minus 4x, 2y plus 5. I'm going to subtract the 5 and then minus the 3xy's to get the y's on one side. So I have negative 4x minus 5 equals 2y minus 3xy. Factor out a y. And then, so divide by 2 minus 3x. So I have negative 4x plus 5 over 2 minus 3x equals our inverse. All right, and on the back side, finding these values. So it's pretty easy when we have to look for f of 1. So f of 1 is negative 2. F of 6 is 1. F of 2 is 3. So for our inverse, we're looking in reverse. So when it's 1, it would be 6. When it's 4, it would be 5. And when it's 6, it would be 3. So again, the easy ones are just f of 2. So f of 2 is 10. F of 10 is 8. F of 7 is negative 3. And then we go in reverse. So our inverse is 7. So that would be negative 1. Negative 3 would give us 7. And 2 would give us negative 3. So if you try these, you should get negative 6, 11, negative 6, negative 10, 3, and 11. So next you're deciding if it's invertible. Identify if the function is invertible. Sketch the graph of the inverse, whether it's invertible or not. So this one passes the horizontal line test, so yes. This one doesn't, so it would be no. And this one does, so it would be yes. And now I'm going to leave this up to you guys, and you can check the answer key. You got to find those points and flip-flop them. So negative 3, 2 becomes 2, negative 3. Let's see. Negative 2, 1, 1, negative 2. 0, 0 would stay the same. Let's see. 4, negative 3, negative 3, 4. So we know it's going to look something like that. That's not the greatest drawing. We need a few more points. So you could find points and flip-flop them. And then the last one, determine if they're inverses. So you need to see if f of g of x, if that equals x, and if g of f of x equals x. So f of g of x, so f of 1/3 x minus 5/3. So f, so I'm going to go to my f, so 3, replace the x. So if I distribute the 3, that would be x minus 5 plus 5, which would just be x, so that works. And g of f of x, so g of 3x plus 5. So 1/3 times 3x plus 5 minus 5/3. So if we distribute, that's 1x plus 5/3 minus 5/3. So that's just 1x. All right, so does f of g of x equal x? And does g of f of x equal x? So f of g of x, so f of x cubed minus 3. So we got the cubed root of 3 minus x cubed minus 3. So the cubed root, if we distribute that, minus x cubed plus 3. So this is the cubed root of 6 minus x cubed. So that's going to be a no, because an x does not come out. All right, the graph is linear. Let g be the inverse. What is the minimum value of g? Well, if I look at this, my domain is negative 3 to 3. And my range is negative 4 to positive 2. So again, it swaps. So this on my inverse, this is the domain, and this is the range. So if I want my minimum, it would be at negative 3. All right, and Mr. Brust is filling a backyard kiddie pool with a water hose. The amount of water in gallons in the pool T after he turns on the water can be modeled by P, an increasing function. Okay, so it's increasing. The inverse of P. Well, I'm going to just give some points. Maybe this is 1, 1, 2, 3, 4, 5. So if I was to do the inverse here, let's see, 1, 1, 3, 2, 5, 4. So what happens here? Well, if it's increasing, oh, well, just in terms of words, I guess we don't need that. If water and time are increase, so water increases as time increases. So what would be the inverse then? It's an increasing a function of the amount of water in the pool. So letter C. And then this one is a calculator one. So you're going to have to go back and, well, maybe we can do it without. So our function, we have to find at h of 2. So h of 2 is g of f of 2. All right, so f of 2. So you got to evaluate g of negative 10 is. So this would definitely be a calculator. So this would, if you type it in your calculator, you get this. All right, find the value of the inverse at 1. So f of 1. So we're going here, so we know it's our inverse. So going backwards, that would be 4.